Hello and welcome friends to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So whenever you design something, a mechanism or say machine or a system, so in that case the FMEA, the failure mode and effect analysis, is very important. Many times the customer wants that you should carry out the FMEA before the machine get dispatched. So what actually it is and how we can calculate the risk priority number, what it is. So all these things are very important, so we should know these things. So let's get started. So here is our sheet of FMEA worksheet, and the spreadsheet we can use it first, like to identify the potential failure modes and their impact on the product reliability, right? Then rank potential defects to establish the priority, the RPN, the risk priority number, to find out the risk priority number, and if the risk priority number is high, so we have to give a higher importance to that failure, right? And then we can capture the action plan, status, etc. So what we have here, description that will explain the spreadsheet skills, FMEA, the actual sheet. We have to enter the data. Then we have guidelines over here, and then we have a simple example to understand what it is. So let's start with the description. So now here you could see the FMEA worksheet, the potential failure mode and effect analysis, right? The title is here, so that is design FMEA, the system, the subsystem, then component design lead, core team, what are the members, and FMEA number, prepared by whom, the date, the revision date if any. So all this data you should fill it, and then we have a sheet here. So let's start that what it offers. So first, what we have, the item or function over here. So what it is, like here, coolant contaminant or hose connection or coolant fill. So this is the actual function. Say what is my function and what are the potential failure modes of this function, right? I have a coolant, I have a hose connection. So what is the failure mode? What are the failures? The hose can crack or break, the hose can burst, right? So sealing can be bad, so poor hose retention. So we have to write down the failure mode, the potential and their consequence. That means because of this failure what will happen. So what will happen, the potential effect of failure is what? Leakage, right? There is a crack, if there is a bad seal, what will happen? There will be the leakage of the oil. So that is my potential effect of my failure, right? So we have to list down here, and then we have a severity. Now what is severity? The severity is like what is the severity of my failure. We have to scale it on 1 to 10. 10 is like highest severity and 1 is like the lowest severity. So let's check out its rating. So here you could see the effect and the severity of the effect. So and the ranking. So hazardous without warning, that means something is happening and it is not even giving any kind of alarm. So if this is the case, you should rank it to the 10, because it is the highest priority. We are not getting any kind of alarm system from the machine, and that may that will lead to a very dangerous accident also. So that's why we have to rank it to the 10s. Then we have different categories. We have a high, then moderate, very low, or very minor uh, system, a very minor effect, and its severity is less, so we can rank it to lesser number. So this, on the basis of these guidelines, you should give a severity number to a particular potential failure mode. So this is how. Then we have given 8 number. Then what is the potential causes or mechanisms of the failure? That means why the it is happening. So it is getting burst. Why it is getting burst? Because of the overpressure. So that is my potential cause of the failure, right? So you have to list down what will be the potential causes of the failure, and then because of the overpressure, right? And we have then the probability, or that is nothing but the likelihood. That means what is the probability of happening of this failure. So this is the probability. So we have to again scale it on 1 to 10, like a rate the likelihood of the failure. So 10 is the highest, that is most likely. That means this will definitely going to happen, or it is most likely to happen. So that failure we will give a probability of set probability number of a 10. So here you could see the probability of failure, that is very high. The failure is almost, we cannot avoid it. So what is its probability? Like in two failure modes, for one time it is going to definitely fail. So that's why we have given 10 number, right? Then we have a high failure, then moderate, low. So you could see one probability in say 2000 or 15,000. So if it is happening for say one time in 15,000, its probability is very less. So we can accordingly give the number. Then what are the current design controls? Right now here our machine design comes into picture, that what precautions we have taken care in order to avoid this failure. Whether we have taken some pressure sensor, some burst control mechanism, or say we have validated the machine. So here we have to write down what are the current design controls. What are the current controls in our design that we have taken care against this particular failure. And then there is a detectability. That means we have to examine the current design, and then we have to scale it from 1 to 10, the rate of detectability of each failure. 10 is like very less detectable. That means uh, I haven't taken care of anything in the machine, and that's why that failure is very less detectable. So as it is very less detectable, the probability of failure and the effect is very high, and that's why we have to give a ranking of 10 to that thing. So here we have a detection and likelihood of the detection by the design control. So absolute uncertainty, that means design control cannot detect the potential cause. There is no such mechanism involved in the machine that will take care of that, and that's why we have given the 10 ranking. Then again we have low, moderate, high, very high. So very high detection capability, that means we have taken care, we have given some sensors, some mechanisms that will prevent the failure. So all these things have been taken care, and that's why the detectability is higher and the rank is lesser, because we are multiplying all these factors, right? So if the detectability is high, the failure effect might be lesser one, the failure probability is lesser one. So we have given the detectability as 1. So the RPN, the risk priority number, is the combined weightage of all these things. We are multiplying the severity, probability and detectability. Here you could see 8 into 8 into 1, that is 64. So that is my risk priority number. So this is very important number. We have arrived to this number, right? So if this number is very high, you should give important. Then recommended actions, what actions you have taken care. We have tested the prototype during the production. Then who is the responsible and what is the target date of completion, that how you are going to complete the target. So that you have to write. And then the very important thing is the action results, action taken. Then what is the new severity, new probability, new detectability, and the new RPN number. What does it mean? That how what are the actions you have taken care, what additional things you have given, and the before that the RPN is like this much, and after including the factor, how it has gone improved. So this is how the FMEA is carried out, and this is a very important document, say. So let's take an example. Here we have design verification process here, and uh, we have, say, first is customer sends in a code request for a product. So this is my function. And what is the failure mode? The system software integration shipping requirements. or overlooked, right? So there is some failure and potential effects of failures where customer needs not fully satisfied because I have not got its requirement. The severity I have given 7 potential causes like human error. Someone might not have seen the mail, probability is like less, so 1. And current design controls, what we have some configurations tools, so detectable is 3. So my RPN what we have arrived is at 7 into 1 into 3 is 21. So this is how you can just segregate what are the different parameters or in your system, in your machine. So you could see this is a spreadsheet which is editable. You can just change the number and the RPN number will get changed. What are the recommended actions you have taken care of, and the responsibility and the closing date. So this is something you could see here, the n number of different things. So you can prepare this complete sheet for your machine, mechanism, system, whatever things you have. And customer sometimes wants it prior to the machine dispatch, so that he can look out that what uh, precautions you have taken care to avoid the failures in the machine, or even if there is a failure, how the severity is going to affect, and what precautions have been taken care to reduce the severity. So this is all about failure mode effect and analysis, failure mode effects and analysis. And this is very important, and the highest RPN number item deserves the most attention. So the aim is to find out the highest uh, RPN number, and then we have to take the actions. So that is also important, that what actions we are taking against the failure mode. So this is all about the FMEA, and this is very important parameter in the industry, and you should know about it. So if you want this spreadsheet, so just do write into the comment section, and I will drop the Excel sheet over there. So this is it for the today's session. I hope everyone understood about the FMEA, the importance of FMEA, and what are its parameters and how it is carried out. So thank you for the patient listening, and if you have any doubts, please do write into the comment section and we can discuss over there. Until then, stay home, stay happy. Thank you.